So today I'll be using MDTools, showing how to design a manifold. Last MDTools webinar we made last year was with MDTools on Inventor. So today I'm going to use MDTools on SolidWorks. And during last webinar, I was designing with a diagram not made with HyDraw CAD. So today I will start from a HyDraw CAD diagram. For those using MDTools on Inventor, there are no major differences in terms of commands and interface. So what you will see today is doable also in Inventor. It's only the basic CAD platform that is changing. You are looking at the diagram that we are going to design today. Of course, in a limited time frame like we have, we cannot make too complex stuff. So today I'll try to design completely and assemble and make the machining drawing for this manifold. We can just look in a bit. Normally, people designing manifold will start taking a look at the diagram and will try to identify how the connections are made. So usually they try to color. Maybe they will say this net is called P, and there is a large tank net here. So people designing with diagram on paper normally take color pencil and try to define the net. During last webinar, I explained how to build a net table to help when you don't have a HyDraw CAD diagram. So to help identifying the net information, the connectivity information for each component in the diagram. So today we have a HyDraw CAD diagram. So in HyDraw CAD we can use a command that is called net. And when we run the net command on a manifold diagram, this command is able to find to read the connectivity information in the block. When doing training, I always recommend to rename net. So in this case, you see that I have already given name like A1, A2, B1, B2, C, EF1, P, PF1, and so on. By default, when you run a net list command, the HyDraw CAD will name all nets, net 1, net 2, and so on. You can just rename nets quickly just by typing a different net name, and that will change. Specifying a custom net name may help a lot when you design, mainly if your block is complicated, if it has many net. In this case, although we don't have many components, but we see that we have about something more than 10 nets in this block. HyDraw CAD makes the net list and then is also able to export to MDTools. In this case, I have also linked to each symbol in HyDraw CAD also a 3D model. So you can see here this valve is linked to a 4W6 Bosch Rexroth. We have RDDA Sun hydraulics valve with the corresponding solid part file. Of course, if I need to use Inventor, then I would switch to IPT files. But in this case, today we are designing with SolidWorks. So when we export from HyDraw CAD to MDTools, we use the MDTools command. We select the envelope, and on the left we see all this item here. So we have the list of components with different icons describing if it is a cartridge or if it is a footprint or external ports and so on. You can also look at nets, and again you can view the net highlighted in the diagram. And if you select a single component, this component can have a preferred face. In this case, I leave all. I will try to design the block without specifying any particular constraint, but also the component will have a 3D model. So in this case, it's a HIDAC valve, and I have the cartridge and the coil. Now, to design this block, I will just export. So when you export a diagram to MDTools, you will just create an XML file that can be used directly in MDTools. And that's my manifold block diagram. And now I can switch to SolidWorks, where I will start my design. MDTools is a plugin for SolidWorks in this case, so you will find it under the add-ins, and you can switch it on and off in the add-ins. I can start a new part, and the interface is almost identical in SolidWorks and Inventor. On the left, we have our browser divided into model browser, cavity library, and HyDraw schematic. So today we'll design from HyDraw, so we'll load the schematic. So let me do straight away. Select the schematic, and I will load my manifold block diagram. Now MDTools is reading the XML file containing all the information for the diagram. And on the left, within a few seconds, I will be able to see all the item numbers in the diagram and all the external ports in the diagram. Some settings. So today I'm going to design in millimeters. My precision is 1 decimal place for location, 0 for drill depth and inclination, so no decimal place. You can specify the cavity color, standard cavity color for your default nets. So when you specify a color, let me do as an example. In HyDraw CAD, I specified a net called CYL for the cylinder port. And let's say that I need that net by default always green. So when you define here a net with a name and a color, when you import the diagram with that net, it will always be that color. By the way, the color is just an attribute of the net in the block that you design. So if you need to change color to a net, you will be able to do during the design process. Something important is in the construction port. So today I'm going to use SAE short port plugs. So I will load my library. Just a second. And I will load my short ports, SAE plugs. I will take all the SAE plugs for my design. Again, the plug definition is an attribute of the block that you design. So you can change plugs by each type of block you make. When you click apply, these settings are applied to the block you design, and then we can close the settings. So now I have loaded my diagram. Let me start my block design. So I will start with a dimension 150 by 120 and by 100. And we start placing component. There were two Bosch Rexroth NG6 valves, 4.1 and 4.2. So let's start placing them. We can rotate them, and we can define a position, 40, 50. I take also the other one, place, and rotate. It is possible to place component with a fixed distance from another one. So usually in this case, I try to change the reference and take the same bolt in this case, and define that I need 60 millimeter 0 to keep the exact same alignment. As you see, when we place the footprint, we already have the engraving, so it's easy to identify which component is in the diagram. And I just switch back to the diagram, but I will not look at it anymore. We can see that we have item 4.1, 4.2, and so on. This is the exact same item number that we see engraved in the block. It's interesting because we can design by net. So we can switch to the net and we will see the net name and the color. So maybe here we can start taking the A2 port and insert here and connect directly with the correct port. So we connect directly here. And we can change to 8mm the connecting diameter. We can go to the center, and we can also change a bit of position. Let's make it 17mm from the corner. We can do the same with the yellow one. B2, insert, touch, and connect. Now I want to keep a fixed distance from A2, so I will switch reference to A2 and keep 0 and maybe 45mm. And again, I can define a diameter of 8mm. This is the easiest part actually, but let's start from the pressure. So we want the pressure on the right. And let's put it at 90 70mm. And we have 3 valves connected to the pressure line. Let's start with the flow regulator 3.2, and we insert it and place it here and connect in the center. So I can connect in the center, and I can define a different position, let's say 100mm 70. Now we can see a similar color, and I decided to change face, to put all the ports on the opposite face. So I can use a command called change face, and I bring B2 here and connect to the yellow port. And I want to put a reference to this port at 0, 0, so that I really can quickly use other cavities as a reference point. I can connect my drill here in order to reduce the depth of the yellow connection, and I can again do the change face and position here and connect and position with reference to this cavity at 0, 45. So here I want also the other flow regulator, so I go back to the cavity. So we can design starting from cavities or from nets. Now I get back to cavities and take item 3.1. It's the other Danfoss flow regulator, NCS 12.3. So here, when we select a component, we can see the cavity information and also the port information. We can insert and place the component here, and let me put at a fixed distance, let's say 50, 0, and I put it here. I see this cavity are intersecting, so everything you see with your eyes should be modified immediately. It's of course a mistake, but if you don't see with your eyes, you can run the connection check in this case. So connection check will help us identifying the mistakes we make in the block. So in this case, I'm running the connection check, which is highlighting that there are a dead area, working area intersection. So 4.2a port is touching the cavity 3.1, A2 is touching also the same area, and there are also wrong connection. So basically, wrong connection means that the 2 nets that should not be connecting together are really touching. So that's for sure a problem. So in this case, I'm going to move my port up by 5, 10, 15 millimeter, and I connect here so that I get rid of that error. In this case, we have some engravings overlapping. So if you need to move an engraving, you go to Engraving Text, Edit. You take the B2, which is the engraving I need to modify, Edit, and I can just specify a new location, maybe here. Okay, to store that location. It is also possible to align engravings. We can use the align engraving command to select an engraving and align with the other one. Align command will not ask the direction. It will align, in this case, on the X, because it's the shortest distance. So it will just compare the position and make the same X or Y according which is the minimum distance between the two engraving text. Let's go back to the nets, and we want to take the tank, and I take the T-port, insert and place here, and I can directly connect to port number 2. So having the colors help really with making a faster connection. That's our T-port. And now I want to connect this tank line directly with an inclined connection. So I can do a stretch and incline, allow an inclination, and go directly to the tank port. If you try to make a larger drill than what is allowed by the footprint, let's say I want 8 millimeter, then you will have a warning, and MDTools will give you the value of the maximum diameter that you can make in order to be able, in this case, to not have problem with O-ring on the NG6 valve. So 6.8 is the maximum I can do. So let me make 6.5. And this is something I normally do. I try to reduce the number of tools that are needed by the manufacturer. So I have a 6.5 tool. Let's use the match property to copy this diameter to all the other drills in the footprint. So I touch all the other drills and copy just the diameter. It is possible to copy alpha, beta, drill depth, and so on. In this case, I just need the diameter so that all these drills will have a 6.5 millimeter, and there will be less tool change in the shop floor. P-port, T-port and the P-port of 4.2 will be connected, because in this case we have not a parallel circuit. So in order to make a connection, sometimes people make inclined drills like this way. I don't like to use too many inclined drills, so I will make 2 plugs and a cross drill on this face. So let's try to do that. So I will run the export command. Export command helps us with the building construction ports. I touch the destination cavity, and I can select a different drill. Let's take a SP2, number 2, and I place it here. Position is good. Let's make it around 85 millimeter position. If you want to flush this cavity, you want to have the plug disappear below the face, you can run the flush command, touch the cavity, and automatically MDTools will sink the cavity so that the plug later will not be visible outside the manifold face. I can copy the same plug here, position here, and connect, and click OK. At the same time, I can make again copy and place my plug here and connect with the 2 drills. In this case, I can decide the position, so I can move the arrow, and I can define maybe a 20 by 20 millimeter. And here I made my connection. Let me save my block. So now the access flow for the first priority valve will go in the inlet for the second priority valve. So this is helping, the color will help me identifying what I need to connect. So let me make some room here. I move this cavity by 10 millimeters. And I'll make a construction port on port number 2. Let me take a short port number 4 here. It's small, so I can use the replace command and take a larger one. And you can change really everything. Let's use now a 3x8 BSP port. I keep the drill depth, and I can connect. So in this case, I'm mixing a bit with short port and BSP ports. I can stretch my drill, and I can copy the same drill, positioning here, connecting in the center. And again, I can do the same. I can copy and position and connect also with the other plug. And I have made my connection. Anytime during the design, you can run the connection check. Connection check will help you with finding what is missing, what is not connected, broken net. So we can see that a lot of items are missing, but slowly at the end of our design, we will not see any more item here in the connection check. Let's move ahead. We go to port B1, insert and connect. And we can always use reference to the other cavity. Let's keep 60, 0, diameter 8. And we go to A1, insert and connect, and position with reference to the same other cavity at 60, 0. By default, the engraving is always put down the cavity. So in this case, we'll need to move the engraving. So B1, edit, and we can change the position. A1 is good there. I forgot to change the diameter. When you need to change the diameter of a cavity, you touch and edit, and you can change the diameter as a step 12. Let's make it 8 millimeter. Or same command, stretch, and you can change the diameter. If you click here, available tool diameters, you will be able to find and select a tool from the available diameters that you have defined in the library. So in MDTools library, you can define all the diameters and maximum length. So this will help with finding the correct diameter by the geometry, required by the geometry, so that you don't have problem with your manufacturer. Let's move forward with the design. Let's put a relief valve and unloading valve. So let me put item 5, and I put somewhere here. This is the unloading valve. So let me change face and put it here. I want to position it somewhere here. So in this case, I will use the test point, MP. I'll put it maybe here, connect with port number 2. And I put at 125, 35 millimeter. And I'll make a construction port here. with here. And I'll take a short port number 6 on the top face. Again, I want to flush this. And I can take my tank line here. I will reduce slightly the diameter to 15 and stretch up to here. And now I want to make a construction port here. I will need some material here, so let me stretch the block and make it 160 millimeter. Now I want to make a construction port to close the tank line. And let's put it here. And again, we can flush. Let's run again the connection check. Connection check now, as you see, it's listing not many items. And there are these 3 ports that are not connected. And this will be a bit tricky, but now we'll find a way to do the connection. And let's do that connection. So I need to connect the pink with the pink one. So I will put a construction port here, a small one. Let's take number 4 here. Let's move it up a bit. And I use a command called move multiple to move all these items down. Now I make another construction port here. Well, let me copy the same one. Copy and put it here. I'll connect these 2. I need a construction port at the same time here. Here, although there will be a wrong connection, later I'll add some material. So now I see that I'm touching the brown connection, but I'll add material there later. And now I make a construction port here. And I make my connection here. So of course now we have introduced a lot of problems in the design. So let's do some change face. This cavity will go here, and we put it tangent and maybe less. And we move this pink connection slightly down. Something interesting is that in this case, we could do a connect cavity. And so we can connect this cavity with the other one, and we could keep a minimum distance of, let's say, 6 millimeters from this cavity here, up or down. So sometimes this is helping finding a good geometry, a good connection in the block. Let me connect. And also I connect the pink with the pink one. And in this case, I will do something strange. I'll move this plug here. It's not that easy in this case. I will do a bit of, I'll delete this plug. I'm going to replace this with a larger one. Let's take a 1x4 plug. I'll move it here. I delete this plug. And now I want to add 2 offset hole to make the connection. So I will make an offset hole here. Let's put it 6 millimeter. And I put it -2 millimeter. And I will do a stretch and incline going directly to that. And I'll do the same technique, offset hole, 6 millimeter, 2, and I go stretch and incline. I will move multiple slightly up. We can verify. Let me move. We can verify minimum wall thickness. I'll do that in a minute. So we can do a wall thickness check between maybe these 2 entities. We can check for 3 millimeter and start. And we see that there is only 1 millimeter here. So that is not good. And we are going now to do some change to our design. So we will need some material here because the pink line is too close. So we will add with the block command, we will add some material on the height. We will put some material here. And we add the 5 millimeter. If you have any question, feel free always to post them. And now I have some room so I can see that this drill can be deepened. Match properties, I can copy the same drill depth. Select all. And I can move multiple, these 2 drills just down a bit. And in some cases, you may want also to reduce the, sometimes it's acceptable to change a bit of, edit all parameters. I will make this drill a bit shorter. And same here, edit. Any special situation can be handled. You can edit a bolt and go and change. Of course, anything special must be control verified with your supplier. And let me edit this and make it 1 millimeter. In this case, this geometry, I will need a larger plug. So let me replace this with a larger plug. Let me take a 3x8. And let me do again all my offset tool. And again here. and this can be reduced 25 millimeters, even 20. Let me just place another valve, and let's put just the port, the cylinder port, and we put it here. And although there in the diagram there should be a valve, this directional control valve connected to the cylinder port, now I'm not going to place it because otherwise I'm not able to finish my circuit. So I will connect directly the cylinder to port number 3. Of course, this will be an error. As you see, this is green, and I'm going to connect it to the blue line. And of course, in this case, there is a valve in between, so I will need to do some techniques. So let me put a plug here. I'm going to stretch my plug up to here, and I'm going to incline it. Let's incline it by 270 degrees, 90 degrees. Okay. And I'll move my cavity slightly to the left. And I will connect these drills. Of course, now they have different colors. So if I connect them and run the connection check, then that will be a wrong connection. So as you see, this will be a wrong connection. But in this case, I will accept it, or better, you can edit the net and change it PF2, so that there will be no error there. So let's do again the connection check. And now that error is not there anymore. There is another mistake here. So this I forgot to fix earlier, but now it will be easier to fix. And all the rest, there are a small, in this case, that's a dead area intersection. So you see here, let me try to highlight it. The blue connection is touching the gray area, which is the dead area. It's a thread. This is a very small, tiny problem. It's not really an issue, so we can live with it. But when you find anything in the dead area to working area intersection warning, you should look for this kind of issues. A drill with oil flow that is touching areas that should not be touched by connection. Anything that is in the wrong connection is a failure in your design. So now let's fix it, and then I'll jump to the assembly. Let's find a solution. There may be yes. I'll change everything. I'll change by 90 degrees. So I'm going to really change entirely the way I made the connection. So I'm going to delete this part. I'm going to stretch it by 50 millimeters and make it 20 degrees. I'll match properties. So here I have a good good spot for making the connection. So let me put a plug here. Let me take a short port number 2 here, and I'll stretch up to this cavity, and also I stretch it here. So in this case, when you have inclined drills, the connect cavity will not work. So you can apply the same net by editing this component and change the net type manually. So you can, it's called PS in this case, or you can use the match properties between two drills, and you can map port 1 with port 1. That's the same approach. So you can edit and apply a net to a drill, or you can do something like I did. So I can change face now to this drill. Change face. This one. I will put it here and connect. I will move my drill here. And do my connection. So I will copy. And I connect. Okay, now if we do the connection check, this will not list anything else. There are some poor connection, which means a drill, in this case, this connection is not smooth, so we can fix by using the align command. And we can extend a bit this drill. And again, so if we run again now the connection check, that issue will disappear. There is another one for another drill, but let's live with it. And we can do the wall thickness check. So we can check for the wall thickness around all cavities. Let's say we can verify for 4 millimeters in all our block. And then here we have a list, not many items, 3.2 millimeters, 3.9, 3.7. So you can go through and fix if anything has to be fixed. So in this case, for instance, it's a distance with this tank line, and we can really quickly do the change, move to the right and fix that. In this case, I've been designing in virtual mode, so I'm going to feature mode by running convert. And normally when I design in Inventor, I never use virtual mode anymore. But in SolidWorks, I still find it better because I can reach faster to a solution for a block. But you can design always in feature mode in both Inventor and SolidWorks. Usually, you need a virtual mode when you see that the system is slowing down too much. So it's better to go for the virtual mode. I see here we can make a better connection. Connect. there is no real difference between feature and virtual. They have all the same command work. We can all flush. For instance, I see some cavities to flush, so I can flush all these cavities in one go. And now I'm going to do the assembly. You can do all the checking and all the commands in virtual mode and feature mode. You can switch between virtual and feature mode by using the convert command. Let me save the block and go to the assembly, new assembly. If you remember, I had all the components linked in the XML file. So in this case, the assembly will be automatically, so I can run automatic assembly. MDTools will show me the list of all the items that will be assembled automatically in the block, and I can run assemble. So now MDTools is taking the 3D model that were linked to the cavities in the block, and is going to assemble them. So here we are. We have the valves, all the plugs. Let me manually assemble the other NG6 valve, which probably had not been linked. This anything in this case, it does not like it, so you can still mate with the inventor or SolidWorks command. So we can do the mating. Mating. Okay, and we can also assemble other items like the test point. So we can go and in MDTools use the assembly interface. We can select the MP, for instance, and go and assemble different items. Update. And here is the test point assembled. I want to show you also the machining drawing very quickly. Let's switch back to the manifold block. So I will run one command called machining ID. This command will give to each cavity in the block a unique ID. Letter for a face and letter for the cavity, and identical cavities in the same face will have same letter and different number. And now I'll make a new drawing. I take my A0 size and I will create views and take my block. Now MDTools is now placing all the standard 6 views of the block and placing in the drawing. If we zoom in a bit, we see the engraving, we see the direction for the inclined drills, we'll see a cross for the construction plugs, origin, face name for each drill. We can show the machining ID, which is basically that letter If machining IDs are overlapping, you can just move them very quickly in each phase. And let me save my drawing. You can make the drill chart, and the drill chart is configurable. During one of the next webinar, I'll show you in details how to configure a machining chart. Insert in the drawing, and we can just take the top left and bottom right corner. MDTools comes with a pre-configured drill chart format, but you can really customize and define your rules for the drill chart. So this is the drill chart with all the information, and the drill chart has also the meet list, which is the list of intersections in the block in order to be able to verify better. So in this case, for instance, BC cavity, it's a Comatrol NCS 12-3 with a bottom drill 19 by 92 and is touching the cavities AL, EB, EC, EE, and so on. Last command is the auto dimension, but I run it and we can close. I don't see any questions. So with this command, MDTools will place all the dimensions in each views in the block.